Remember Superman? He could leap over a building with a single bound. He could also bend this with his bare hands. Bridges, skyscrapers, appliances, our lives revolve around this material called steel. Steelmaking usually begins with a pile of scrap metal. Using this 10-ton electromagnet, scrap iron composed of crushed car bodies, electric appliances, cans, and other steel scraps are gathered up. This powerful magnet is able to lift 5 tons of metal. About 83% of this scrap will be transformed into bars of steel. This metal is then dumped into a basket, which, by itself, weighs 32 tons. The basket can hold up to 60 tons of metal, and now they're going to melt the metal. This furnace reaches a temperature of 1650 degrees centigrade, hot enough to liquefy the metal. It is heated by 3 electrodes and by 4 natural gas burners. The contents of the basket are dumped into the furnace. Here, the pieces of metal come into contact with liquefied steel, which always remains at the bottom of the furnace. There's a reaction, and an aeration system draws out the smoke that's produced. At this high heat, the 60 tons of metal will melt in about 60 minutes. Then the cover is placed on the furnace. This liquid is composed of impurities, which rise to the surface when the metal becomes molten. At this stage, a workman draws a sample of steel to determine its chemical makeup. And now they make use of a supersonic oxygen lance. This lance blows oxygen into the molten steel, which reduces its carbon content, homogenizes the mix, and then speeds up the melting process. A ladle is positioned beneath the furnace. The molten steel will be transferred from the furnace into this ladle. The molten steel easily pours into the ladle. The ladle weighs 55 tons and holds 115 tons of molten steel. An overhead crane capable of lifting 180 tons carries the ladle filled with steel. Additives are introduced in order to obtain the correct steel tone. Here, the electrodes are taken out of the furnace ladle. A workman now opens the pouring nozzles of the distributor, equipped with 4 pouring holes. The molten steel runs into molds. It very quickly cools and begins to harden. Steel billets are produced in lengths varying between 4.5 meters and 10.6 meters. The billets are then cut to the desired length with a natural gas torch. A pouring identification number is marked on them with a wax crayon. The difference between a steel billet and the nearly finished flattened product is clear. Flattening of the billets remains to be done. Before flattening begins, billets are placed in the furnace to be reheated for 2 hours at 1095 degrees centigrade. Water jets cool the billet ejector. The billets are placed on the flattener, where powerful rollers compress them. This operation gives the billets the required shape and size. Water-cooled rollers crush the billets. Some billets go from a thickness of 12 centimeters down to 14 millimeters, while others reduce from 15 centimeters down to 19 millimeters. At the end of production, bars move along at a speed reaching 35 kilometers per hour. Once reaching their required dimensions, the bars must be cooled. This cooling bed allows the steel bars to cool uniformly. A total of some 400,000 tons of steel bars are made at this plant each year.